Now that everybody's in the room ready to participate, what is your favorite function? I don't mean exponential. What is your favorite function? Let's start with John Mathine. If you had one function you wanted for Christmas, what would it be? You got to pick one. Who? AX plus B? That works. What type of function is that? That's a linear function. We just talked about that. What other type of functions are there? Linear makes a straight line. Colin? Good. That makes a quadratic function. Quadratic. Why? It comes from the quadratic formula to solve. Yes, Miss Bensel. Another type of function. Cubic. Very good. AX cubed plus BX plus da 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 da. So, all these functions, cubic, have unique characteristics and unique graphs. Let's see. What else? Is there? Let's do one more. Square root function. Square root of AX. Looks something like this. Takes off and goes that way. They all have special names based on the equations that they work with. So, on this one, the exponential function. First of all, function means it passes the vertical line test, correct? Second, what do you think exponent means? Drew, this is your chance to remove the stigma of doing nothing. Never mind. Nick, exponent, what does it mean? Right. What's the first letter I'm going to write? A. B to the x. Exponent stands for the fact that the variable is in the exponent. There is. That is multiplied between the a and the b. Some things about the exponential function. One, b cannot be negative. It has to be positive. B has to be positive. Yes.
Is the x only to the b then?
Right. The x only goes with the b. Correct. So I can put it like this if I wanted. Yes. B has to be greater than 0, so it can't be equal to 0. Otherwise, you'd have a constant function. B cannot equal 1. Otherwise, you'd have a constant function again. So this has to be true because it has to be constants. This has to be true. B has to be greater than 0 to ensure that there's an inverse. If you let B be anything, you wouldn't have an inverse of the exponential function. We need an inverse to solve exponential equations. So that's why B has to be a positive number. A can be anything it likes. A can be any number you want. A outside the function, remember how it reacts with the function? What's it do? What's A do outside the function? Right, it's a vertical stretch or compression. So that's a vertical stretch. Vertical stretch or compression, however you look at it. B, when it's inside the parentheses, what's B do to our function? A, F, to B to the X. What's B do to a function? A what? Yeah, it's a horizontal stretch or compression. So, whenever you have a B or an A, there's going to be a stretch or a compression from your original graph. So this is a horizontal stretch or compression. Okay?
Same as all others, right?
Same as all other functions. Except we need a basic idea of a graph. So if I just had A, B to the X graph, one very important thing. The domain is all real numbers. Okay? Domain is all real numbers. Always on an exponential graph. Now the range, on the other hand, I have purposely taken out all negative values of y because b has to be positive. Does that make sense? If I add 2 to the x, I could put in -1 and get a half, couldn't I? I could put in 0 and get out 1, couldn't I? I could put in 1 and get out 2, couldn't I? However, if I had -2 to the x, I put in -1, I get out -1/2. I put in 0, I get out 1. I put in 1, I get out -2. I've taken out all possible negative values of y because I made the base positive, and only positive. So, that means since the base has to be positive, the range has to be greater than 0. Good. So the range has to be greater than 0. In other words, if the range is greater than 0, that means there's a horizontal asymptote at y equals 0. This should all go into your cheat sheet of information for exponential functions when we have our chapter test after the break. We'll have a chapter quiz before the break. We'll have a chapter test after the break. No, this sheet ensures that you remember everything you did less than a month ago. I know. I can't believe people expect you to remember things like that, but I am one of them that do. Luckily, I have the videos so you go back and listen. Yes? No, this is just kind of like a time capsule, so to speak. When you come back after break, you can open this up and say, oh yeah, I remember all that stuff. Because you're expected to. Nice. My goal is to have the chapter test in before the semester break, which comes 2 weeks when we come back. Okay? But we're going to have a chapter quiz before break. Nice. You over this chapter, however far we get. So, anyway, this is the long and the short of exponential functions. Everything you need to know is pretty much right in here. Except how to type it out. We'll go over that in a minute. Also, by order of operations, exponents trump multiplication. You cannot write this as AB to the x. You cannot write AB to the x. You can't multiply first, you have to do exponents first, okay? Why do I say that? Because not embarrassed, the kids have embarrassed themselves. When I say, what's the first step in graphing this function? They instantly say, oh, that's 10 to the x, let's get started. No, you can't do that because you have to put in the exponents first, order of operations, multiply second. Okay? Don't get too excited, don't get too carried away. That's fine. Moving on, as we like to say in the show. So, A is the base. Oh, this in case I'm not here. You can read that on your own. Domain is all real numbers. Horizontal asymptote. Oh, this is interesting. Oh, this A refers to this base right here. F of x equals A to the x. And someone say, why did you write it like this last time if A is supposed to be right? Look, it's just the first letter. It depends where you're going to start your first letter. Like in the quadratic, ax squared plus bx plus c. It's just where you start your first letter. There's no B in this one, so that's why I put it there. Anyway, if A is a big number, that means f of x is increasing, so it's a one-to-one function. If it's a fraction, why is it decreasing? Andrew Manalo.
Because if you put in 1, like 1, or like if you put in, let's say you put in 2 for x, then 1/2 squared is 1/4.
Right.
Right?
Right. I was looking for something a little bit more globally as an explanation.
Okay.
Now wait a minute. You are true.
Right.
This is the difference between an increasing and decreasing function for exponentials. I'm sure everybody has that written down because I've seen some pencils being moved. Now, here comes the big picture answer. Those graphs were reflected over what? Y-axis. So if I had the equation y equals x, let's do this. The negative inside the parentheses flips it over the y-axis, correct? The negative inside the parentheses. And somebody goes, where the heck's the parentheses? I'm going to say, look, you have a TI. The parentheses has to be around the exponential function. How can I rewrite a half?
Third.
2 to what power?
Or the
2 to the
thing.
2 to the negative 1. Did you get that, Drew? Did you get that? Excellent. So this becomes 2 to the negative x. Same base, except the x now has a negative in front of it, so which way is it reflected?
The opposite.
The y-axis. That's why if a is between 0 and 1, it makes a negative exponent. Some people like integer bases. Some people don't care. I'm one of those that don't care. So that's why it's decreasing. This is an increasing function. That's a decreasing function.
So if all fractions raised to a power.
Right, all fractions. You don't write them bigger than 1, you have to negate the exponent. Okay? That's not too difficult. 3 is written how to equal 1/3. 3 to what power?
Negative.
3 to the negative 1 equals 1/3, doesn't it? You have it on your calculators. We'll get to that in just a moment. So, that was interesting. I like that. Moving on. There's an old adage in algebra that when you have the same base, you can solve for the exponents. Oh, yeah, are these the same base?
Are we doing logs?
Not today.
Okay, good.
These are the same bases. So, the 6.
We can set the exponents equal to each other.
You can. So you can set the exponents equal to each other. 3x equals 6. So x equals 2. Remember, in this equation, x, the domain, is all real numbers. X can be anything. So 6 to the 5th equals 6 to the 5th. That's one way of doing it. I'm sure you can think your way through that problem. Same bases, set the exponents equal to each other. If they're not same bases, make them the same base. Easy. Like in this one, they don't have the same base. How would you make them the same base?
Multiply that and then 1/2 by -1.
You don't multiply by -1.
Make it 2.
Now, you have a choice. We'll go to Megan Suits because she's our administrative assistant for choices. Do we want to write in halves or 2s as our base? We have a choice. We can either go base with 2 or base with a half. Which one do you want to do? Base with what? 2. That's our winner. How do you write 1/2 as a 2? Yep.
Or 1/2 to the negative first power.
No, 2 to the negative first power means a half. Now, what do you do when an exponent's raised to an exponent, Devin? What do you do with those exponents? Multiply them. So I have -6 plus x equals 1. I just wrote 2 to the -1 for a half.
Well, I got them switched up. I was doing half.
You could do halvesies. Yeah, so x equals 7. Somebody goes, yeah, but I did it the other way. Fine. 1/2 6 minus x equals 1/2 to -1. Now you can set them equal to each other. 6 minus x equals -1. X equals 7. It works either way. You just have to make a choice and get after it. Not just stand there and act like you're paralyzed. Okay?
Yeah.
Moving on. I think it was a great step to start on Monday.
Start you fronting.
Woo! What base are we going to run to on this one? 27s, 9s, 3rds, 3s, what?
3.
3. So I'm thinking to myself, self, I'm going to rewrite everything with base 3. And this is where people go, why do you take so much time in solving a problem? Because I never get them wrong. That's why. You don't take time, you get them wrong. I take my time, I get them right. It's kind of like playing golf. Have I used that analogy before?
Nope.
Those pros, have you ever seen how long they stand over a shot before they take that shot?
Yes, forever.
And they play a quicker round. How do they do that? They're efficient. Yeah, they take fewer shots because they think about their shots. I did that once. I actually thought before every shot.
Did you miss it?
No, I actually shot very well. It was very hard to do. Almost not worth it.
Golf's always
For sure.
I'm just writing everything with Base 3. Everything that was able to be written in base 3, I've written in base 3. Now I'm going to get rid of all the parentheses. Next step. So I went base 3. Now I'm going to remove the parentheses. You guys have never really been, this is Parkland's big approach. Always remove grouping symbols. Always. I mean, that's in their doctrine of math education, whenever you teach classes. That is a step. Remove grouping symbols. They constantly say that. Because it makes it easier to then simplify. That's the next one. Okay? So when you remove the grouping symbols, that stands for parentheses, braces, brackets, all sorts of things. What do you do when you raise an exponent to a power? We talked about that. So it's 3 to the 4x. You multiply 3 to the negative x minus 2. This one, I don't have to multiply anything. It's already there. This one is 3 to the negative 2x. Now when I simplify this, yeah, I got multiple bases here. What do I do with the exponents when I multiply the same base? Add them. 3 to the what? 3x minus 2 and 3 to the 3 minus 2x. And what's always after simplifying? Who? Did I get rid of the 3's? Then I multiply 2 to 2x, 4x. What are you talking about? Yeah, when you multiply, you add the exponents together?
Yeah, we don't do anything with the base though.
Yeah, you combine it. You simplify it from 2 bases to 1. Remember, we're trying to set them equal to each other. So they have to have the same base on each side and only one base. And what's always after simplifying it? No, solve.
Yeah.
Okay. 3x minus 2 equals 3 minus 2x. Well, because in calculus, when you make one change, you make one new line. If I did it your way, I'd make 2 changes per line, and that would be kind of confusing to some. In your work, you can do that. You mean go 4x, negative x, 3x, jump from the first to the third? Yeah, I'm just saying I show every step because once you make a change, you're supposed to show that change. And once you start doing things like that, you realize that all math problems are pretty much the same. They all follow these rules. It's just the individual techniques change. So here you have 5x equals 5, x equals 1. Woohoo! Nice. I like that. Very nice. Now, some people might do this in, 1, 2, 3, whatever, how many steps. Me? I don't know, 1 change, 1 step. That's usually what you get to because the problems get complicated. All right, moving on. Great. Let's try another one. Sketch the graph. Is A between 0 and 1? Does it look like this? Or is A bigger than 1? Does it look like this?
They're the same.
Oh, it was just 2 slides ago.
No, they're the same.
Oh, sorry. I thought you meant your answer. I was already past this. I had it right in my mind. There we go. What is A?
A is greater than B, 1.
A is not greater than 1. No, the first letter. A, B. See, now it's B in this case. C.
So A is always whatever the...
First constant is. You guys are old enough to learn that truth by now.
No, A is whatever this set has next on it.
No, A is the first constant you always need. Well, because in this problem it is B.
But it's like the first constant.
No, it's not.
The first constant.
No. You're confusing the two. Back when we talked about this, our equation was a to the x. Okay? When a was bigger than 1, we said it was an increasing function. There is no number in front. Therefore, there's no need to write an a. Now there's a number in front. So I need to write an a, so I'm actually talking about the second number, which in the alpha. Right, it's the base. Good. Now we're on the same page. So what's the basic graph of 1/4 to the x look like?
A decreasing graph.
Yeah, it's a decreasing graph. That's pretty much about it. Where's the horizontal asymptote out on this graph? Just on 1/4 to the x. Where's the horizontal asymptote on 1/4 to the x? 0. Well, if I drop it down to, what's going to happen now? This is going to do what? The -2 is going to do what?
Move it down 2 on the y.
Yeah, it's going to drop the horizontal asymptote down to y equals -2. This tells you it's a decreasing function. Decreasing. Drops it down to -2. So the graph drops down to -2. Yes? Yeah, but unfortunately you don't know what's happening, so we have to go through piece by piece when you sketch it out. You understand? For your final answer, yes. But remember how you had to know the horizontal asymptotes and the vertical asymptotes and the holes in the graph and all that stuff? Right, you just have to have that on there. Okay. The graphs are just a means for checking. By no means are they for doing. Oh, because in our original graph, the horizontal asymptote is always at y equals 0.
Calculate y value.
So if I have, you remember f of x minus c, what happens with the c? It's the vertical shift down. So if I'm moving all the points down 2, the asymptote has to get on with it. So, 1, 2. There's my horizontal asymptote. So, it's going to move this point from 0, 1. Where's it going to move it to? What? 0, -1. I haven't addressed the 8 yet. You guys are trying to look at the final answer and make sense of it. Yeah, it's hard to do. So this involves the 1/4 and the -2, right? So far, so good? 0, -1. Now the 8 comes into play. What's the 8 do? It's a vertical stretch, right? So it's going to stretch it up 8 units. Is it going to move the horizontal asymptote? No, it's just going to stretch the graph, existing graph, okay? So, I think it'll stretch this point, don't you think so? Instead of being at 0, -1, you're going to stretch it up 8 units, so it'll be where?
7.
Is it?
7.
Is it 0, 7? Is it?
Yeah.
Are you sure?
I'm positive.
Positive? Oh, no, let's take a look.
Okay, alright.
Oh, I thought you said you were positive.
Well, you said always drive me.
8, 1 divided by 4 caret x minus 2. I did. I put the parentheses. Bum, 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 bum. Hey, there it is, decreasing. Woohoo!
Calculate.
Second, calculate value when x is 0.
6.
6? How the heck did that happen?
0. Oh, 'cause it's 2.
Oh, it multiplied this by 8, and then you dropped it down 2 to get 6. Yeah.
What about for
The 0.01? Because that's if I put 0 in for x, 1/4 to 0 power is 1. That's the original graph. And this is how it changes. Huh? Because you're stretching it 8 units. So it's pulling it up 8. So it's at 8. So we have this graph, 0, 8. And then it drops everything down 2 units. So going 0, 6.
But if it was already F1, would you add 8 to that? Or?
You're not adding, you're multiplying. Okay. There we go. Nice looking graph. Now you understand how all the players are involved. That's kind of crucial when you're solving exponential equations, how things work. Okay? Hey, I can write that. Well, I can write it differently, but I'm not going to. Ready to move on? And we graphed it out. We're in good shape. Do you think? I know it always flies when you're having fun in here. Where do you think the graph's ever going to equal 3? Do you think the y value is ever going to equal -3? Not 3, -3?
No.
I don't think so either, because there's our horizontal asymptote right there. Okay, -2. It gets really close, but I don't think it's going to equal.
Connor said that.
Connor, who?
Wilson.
I know him.
Wait, he said that technically
It is.
does because it's always decreasing. Like it's decreasing at a certain rate or something like that, or like.
Yeah, my 3rd grade teacher pulled this move on me. 0 to 1. How many numbers are between 0 and 1? No, she just said numbers. She was very skilled at saying what she meant. I learned at a very early age. I said, what? She goes, go think about it for a while. So I did.
40 years later.
Oh, no, longer than that. That's the Connor Wilson approach.
Yeah, he says like if.
Well, it's like Zeno's paradox. We talked about that, right?
Yeah, like 0.9 repeated.
No, like if I asked John Mathine to stand up, and if I asked him to cover half the distance to the wall of each step, John Mathine would never reach the wall. If I asked John Mathine to go to the wall, which was 8 feet away, if I said with each step cover half the distance, with his first step he would go 4 feet. Right?
Right. And you go to
Next step he would go 2. Next step he would go 1. Next step he would go a half. Next step he would go. Would he ever get to the wall? No, that's one of Zeno's paradox. You can do that when you're trying to get out of going to work someday. You can say, oh, my car quit. Every time I started it, it would only cover half the distance to work. I never made it in.
You get fired.
College kids don't care. They go find another one. They really don't. All right, so that's one of Zeno's paradoxes. Anyway, this point right here, 0, 1/2. Do you think this helps us find A? Do you think it helps us find B? Or do you think it helps us find C? What's C usually referred to?
line.
No! No! Horizontal asymptote. Where's the horizontal asymptote here? At 0. We just talked about that. Yeah. Can I use my graph to find the equation? No! You got to know what each part means. That's why I spent so much time explaining the other one. Oh, okay.
Something like that.
What do you think the A is going to go to? The y-intercept or this point? The y-intercept. I don't know, is it? 0, you get a half? I don't think so.
Sounds right.
I don't know.
Put
How-
it there.
How the heck are you going to do that?
You just plug in 0 or 1.
Oh, I see. Look. This one, there is no shift. So, I'm using this equation. They wrote it backwards. Interesting. Now the other class, we got this all figured out all nice and quick. If x is 0, oh, this tells me what b is, doesn't it? B times a to the 0. If x is 0, what's y going to equal then? 1/2. So this tells me what b equals. 1/2. Some people are slow to write today. Trevor's got the pencil moves down. He's spinning. Nice. I like those moves. Y equals 1/2. How do I find a? This one. Yeah, plug in x, plug in y, and see what you get. 8 equals 1/2 -2 to the x. Oh my gosh. -1 equals 8. X equals -8. No, these are exponential equations. Remember our first motto? No! To get the same base.
I don't know.
You don't know?
Wait, what's the...
A half times what number gives me 8?
16.
Why are you adding x?
Why is the x turn into a?
Oh, it should be the other way around. I was done with this problem. I was on to the next one. I was trying to get one more problem in because I know we like to get the most out of life in this class.
Right.
All right.
You know us well.
Oh, yeah, there's people that are, never mind. A equals 1/2 a to the -2. How do you solve that one?
Get a by.
Yeah, you have to get a by itself. Just like a square root. Anytime you have something that's hard, you have to isolate it. I can get rid of the half, so I have 16 equals a to the -2.
What?
16 equals a to the -2. Yeah. Do you know if you set the exponents equal, you can also set the bases equal? It works both ways.
Find whatever, like 16.
Yeah, it'd be 4 squared equals a to the -2.
But those aren't the same.
I know. They're close though. How do you make the 2 into a negative on the left? Yeah, 1/4 to -2 equals a to the -2. So what's a have to equal? 1/4. 1?
I said 1/4.
You did not. You said 1. You said 1. Y equals 1/2 times 1/4 to the x. Love that problem.
And you never multiply 1/2 times 1/4.
No! You can write them as the same base if you like. 5 minutes? We have time for one more, I think.
Aw.
We will get the most out of it. You know, there's people actually transferring into this class. They are dreading it.
Wait, next semester?
Yeah, next semester.
This hour?
From 7th hour.
Why are they dreading it?
Well, they hear too many stories about you guys.
Now we're done.
So you talking bad about us?
No, I just say that they're always focused. They actually get the most out of every class period.
Oh.
Huh? No, they like to take brain breaks. You guys don't. So we always take brain breaks every afternoon.
Like the most.
Ready?
We are the most.
Huh?
Number 28.
Yeah. So which one am I going to use? The one on the left or the one on the right? What do you think, Caleb Benson? Left or right? Is why the right? Yeah. Yeah. Because the horizontal asymptote isn't 0. So that means C is going to be +1. What is B going to equal? Which point do you look at for B? Bum, bum, bum. Which point do you look at for A? Bum, bum, bum. Oh, the intercept for B. So B is going to equal 5. A, I don't know. I can't figure out. But I can use this point to help me. Equals 1 or 7? 7. And x is to what power? 1. Is A going to be bigger than 1 or between 0 and 1 in my answer, since it's an increasing function? What do you think, Ms. Jones? You just looked at the clock, realizing we have plenty of time to solve this. Is A going to be bigger than 1 or between 0 and 1? It is going to be bigger than 1. So over here I can solve this, can't I? 5A plus 1 equals 7. 5A equals 6. A equals, is that bigger than 1?
It is at 5.
It is. Now, if you don't understand, or don't understand the last one, does this help? C is a vertical shift. B goes with the y-intercept. A comes from the extra point.
So you just put the 5 in for B, or did you put?
Yeah, I did. I put the 5 in for B.
That's all I have to do.
That's it. We're moving on. What page are we on? 290?
300.
299? 1 through 31 odd? 27 odd. Woohoo! Hope tomorrow just cold, just as fun. Well, sure. Everybody got here in such a good mood today.
It was 8 degrees on the way to school this morning.
8?